Hi everybody. In this video, we're going to talk about the order of operations, and I'm going to give you a way that you can teach the order of operations that relates to the mathematical structure of operations instead of just relying on acronyms like PEMDAS or I've also seen GEMS to teach the order of operations. Because the idea of PEMDAS, or please excuse my dear Aunt Sally, is that you do parentheses first and then exponents, and then you multiply and divide from left to right, whichever one comes first, and then you add and subtract from left to right, again, whichever one comes first. And the other acronym I've seen of GEMS is similar, where you do groupings, which include parentheses, and then you do exponents, and then the M stands for multiplying or dividing from left to right. And then the S is subtracting or adding from left to right. But if you teach order of operations with PEMDAS, there's a lot of common misconceptions that happen when students actually use this acronym. Um, because the way that PEMDAS should be used is you do parentheses, which in this expression, there's no parentheses. And then you would do exponents, but again, there's no exponents. And then you would do multiplication and division from left to right. So the correct way to do it would be to do 64 divided by 8, which would give you 100 minus 8 times 4 plus 6, because if you simplify 64 divided by 8, you get the 8. And then you would simplify the multiplication, which would give you 32 when you do 8 times 4. So you get 100 minus 32 plus 6. And then you do addition and subtraction from left to right. So 100 minus 32 would give you 68, I think. And then you add 6 to that. And when you do 68 plus 6, that gives you 74. So this would be the correct answer with PEMDAS. However, because of the way that PEMDAS is structured and the fact that it's a mnemonic, a lot of students will forget about the left to right thing, that multiplication and division need to be done at the same time from left to right. And they'll just do multiplication first. So the way that many students would solve this problem is they would multiply 8 times 4, which gives 32. So you'd get 100 minus 64 divided by 32 plus 6. And then the next letter is D, so they would divide, and 64 divided by 32 is 2. So you'd get 100 minus 2 plus 6. And then the A comes next, so they would, instead of adding and subtracting from left to right, a lot of students will make the mistake of doing 2 plus 6 because addition comes next in PEMDAS. And they'll do 100 minus 8, and ultimately they end up with the answer 92, which is obviously very different than the correct answer of 74. And so this is one reason why I don't personally ever teach my students order of operations with PEMDAS. Instead, what I use is I teach them the structure of how the operations are related to each other, and I use that to explain why the order of operations works the way that it does. Because as a reminder, the structure of operations is that repeated addition creates multiplication, repeated multiplication creates exponents, and each one of those three operations have inverse operations. So the inverse of addition is subtraction, the inverse of multiplication is division, and the inverse of exponents are roots. And so because of this structure of operations, the order of operations is really simple. You just work from the top of the pyramid and you work your way down. You do exponents and roots first, then you do multiplication and division, then you do addition and subtraction. And if you need to go out of that order, they'll let you know by putting parentheses around whatever needs to be done out of this typical order of operations. So the alternative approach that I suggest using to teach order of operations is to use the structure of how operations are related to each other and just teach the students to work their way down the pyramid. So for example, on this first question, if I wanted to calculate this using the order of operations, the first thing I notice is that I have parentheses. And so the order of operations tells me that anytime I have parentheses, that's a clue that I need to work out of order. So I look inside of the parentheses and I'm going to simplify the inside of the parentheses until I'm all done with the inside. So looking at this, I have multiplication and division inside of my first set of parentheses. And those two operations are the highest operations on my pyramid that are in this problem because I don't have any exponents. So I can just go ahead and start simplifying that. And you always work from left to right if you have multiple operations in the same expression. So I could simplify this to be 2 times 4, because 1 times 4 is 4, minus 2 divided by 2, which is 1. And then I'm going to add the 6 plus 2 minus 3. So that's my first step of simplifying the order of operations. Then the next one is I still need to finish working inside of my parentheses because I still have parentheses here. So when I look inside of the parentheses, I have subtraction, and I also have some addition and subtraction in this second set of parentheses. So I'm going to simplify all the addition and subtraction inside of the parentheses um, from left to right. So for my first one, I'll have 2 times 4 minus 1 is 3, plus 6 plus 2 is 8, minus 3 is 5. And so that second set of parentheses simplifies to 5. Now, in the first set of, or sorry, in that second set of parentheses, I actually don't need the parentheses anymore because adding 5 in parentheses is the same thing as adding 5. So I can erase those parentheses. And the first set of parentheses is necessary because if I got rid of these parentheses, it would look like the number was 23. But what it really means is 2 times 3. So I'm going to keep that parenthesis just to remind me that I need to multiply. And now that I've gotten all of my parentheses taken care of, then I'm going to continue my way down the pyramid. And I'm going to say, well, I don't have any exponents, which I already knew, but I do have some multiplication. So I'm going to multiply these two together, which gives me the number 6. And then I have 6 plus 5, and now I'm at the bottom of my pyramid, and I can do my last operation of addition, which gives me 11. So that's the process that I would think through if I were solving this problem with my method of solving with the order of operations. If I were going to try the second problem here, I would say, okay, well, I do have parentheses, and parentheses are telling me that I need to solve the problem where the inside of the parentheses gets simplified first. And so I look inside of my parentheses and I ask myself, do I have any exponents? Because that's the highest level of the operations pyramid. And I do have 2 sets of exponents. I have these 2. So I'm going to simplify those first. And that gives me 3 times 25 divided by 15 inside my first set of parentheses, because 5 squared is 25. And then in my second set of parentheses, I have 5 minus 4 because 2 squared is 4. Then I still have parentheses, so I'm going to look inside of my parentheses and see if I have any of the next layer of my pyramid. So the next layer of my pyramid is multiplication and division, and I do have some multiplication and division in this first set of parentheses. So I'm going to simplify that. And I'll say, okay, 3 times 25 is 75. 75 divided by 15, I believe, is 5. And so that gives me a 5 inside of that set of parentheses. And then my second set of parentheses doesn't have any multiplication or division. But just to skip a step, I'll go ahead and move on to the next layer of my pyramid, which is addition and subtraction, to simplify inside of this set of parentheses, which will give me a 1. And in both cases, these parentheses are no longer necessary because a 5 inside of parentheses is the same thing as just a regular 5. And a 1, or like if I'm subtracting a 1 in parentheses, that's the same thing as subtracting a 1. So I don't need those parentheses anymore because I fully simplified inside of them. And now I can go through the rest of my order of operations. So I simplified parentheses. Now I check and see if there's any exponents or roots, and there's not. No multiplication and division either. So I get to my last level, which is addition and subtraction, which always happens from left to right. So 5 minus 1 equals the number 4. And that's how I would do it on that one. If you'd like to, you're welcome to try these other two to practice. But that's the basic idea of how I would recommend teaching the order of operations, specifically because it builds on the structure of operations and it's not just teaching the students a mnemonic to memorize. That being said, if you feel like the mnemonic really is the best way for your students to learn, or it's worked really well for you in the past and you have a good way of teaching the students that multiplication and division have to be done in order from left to right. And that doesn't necessarily mean that multiplication comes first. It is fine to use PEMDAS, but I just wanted to give you guys this other alternative to teaching order of operations in case it's helpful. So thank you so much for your time, and I hope you have a good day.